Hey there, fifth graders. Welcome back. Module 2, Lesson 5. And in this lesson, we're going to be using the area model to help us find partial products to multiplication problems. And so breaking up multiplication problems and finding the smaller answers to find the actual final product, that is our job today. So let's get started. So today we are going to be, in the first problem, drawing an area model. And then we're going to be solving using standard algorithm. So two things we're doing. A third thing is we need to use arrows to match the partial products from the area model to the partial products of the algorithm. So that sounds a lot of wordy, but once we kind of go through it, you'll see it's not too bad. So we're doing 34 times 21. So we're going to do an area model. Remember, your area model needs to be fairly big, but don't go over into this area because we're going to be doing some math and we're going to be drawing some arrows. And so we're going to take 34 and we're going to break it up by its place value. So 34 has the number 30 and the number 4. So we broke it up by its place values. 3 tens, which is 30, and 4 ones, which is 4. We're going to draw a line respectively, to show that 30 is definitely going to be bigger than the 4. Now we're going to take 21 and we're going to put it on the left side of the area model, but we're going to have the ones and the 20 kind of go in reverse direction. So the smaller number is going to go on the top and the bigger number is going to go on the bottom, and I'll explain to you why we're doing that when we get into the standard algorithm. Let's draw a line so that this area right here for 20 is bigger than the 1 right here. And so let's go ahead and we're going to be multiplying these numbers together, and we're going to start with 1 times 30. Well, you should know 1 times 30 is 30, so fill that in. And then you have 1 times 4 is 4. And so when we add those together, let's add them together, we get 34. And let's pause and let's actually come over to our standard algorithm. And we started with the 1 in 21. That's why we have the 1 first, because when we do standard algorithm, we start with the 1 in 21. So 1 times 4 is 4, and then 1 times 3, which is 30, 1 times 3 tens, is going to be 3. So now you can see that 34 in the area model matches the standard algorithm, and we're going to draw an arrow. Now we're going to go ahead and do the 20 times the 30. So 2 times 3, that's 6. So 20 times 30 is 600. And then 2 times 4, or 20 times 4, that would be 2 times 4 is 8, and add a 0, and that's going to be 80. So 600 plus 80 is 680. So going over to the standard algorithm, we're not going to just write 680 underneath. We actually want to go through the steps to show that we know how to do it when we don't want to do the area model anymore. We just want to focus only on the standard algorithm. So what I like to do is I like to say, okay, once I'm done with the ones in the ones place, I'm ready for the 2, which is the tens place, which means my answer is going to start in the tens column underneath the 3, which means I need to put a 0 placeholder right here so that when I start multiplying the 2 times the 4, the 8 can go right underneath the 3 and keep everything lined up. Then the 2 times the 3 is a 6, so we get 680, and that matches the bottom partial product. Now these are called partial products because they are part of the answer. The final product means we have to add them together. 4 plus 0 is 4, 3 plus 8 is 11, and 1 plus 6 is 7. So we have 714. All right, let's go to B. B is 434 and multiply it by 24. So make an area model, and then don't go too far over to the right, but make it big enough because guess what? We're going to have to put 3 numbers on the top. The reason why is because 434 has 3 place values. It has the 400, it has the 30, and it has the 4. And we're going to make our area models kind of respectively based on its size of the number. So 400 should be bigger than 30, and then 4 should be a little bit smaller, but you don't need to really worry about it being exact. Now you're going to take 21 and you're going to put the ones first. So we have ones, and then we have 20. And we're going to draw a line going across. So now we have some big pieces and some small pieces to fill in. And we're multiplying these numbers. So 1 times 400 is 400. 1 times 30 is 30. 1 times 4 is 4. So add those together, that's 434. Now if we pretend that we did not do any work and we went straight to the standard algorithm, I'm going to start in the ones. The 1 ones times the 4 ones, that's going to be 4. 1 times 3, that's going to be 3. And 1 times 4 is going to be 4. So this partial product matches the one in the standard algorithm. Also, what I want you to do is I want you to cross off the ones, because we're now going to go over to the tens, and we have 2 tens, and my answer is going to start underneath the 3, which means I need a 0 placeholder in the 1 so that I can start my answer in the tens. This is the tens column right here. So going back to the area model, we have 2 times 4, that's 8. So 20 times 400 would be 8,000, because we have to add 3 zeros. Then you got 20 times 30, so 2 times 3, that's 6. Add your 2 zeros, that's 600. And then you have 20 times 4, or 2 times 4 is 8, and then 20 times 4 is 80. So you have 8,680, so 8,680 is what we got by adding those up together. And if I went back to the standard algorithm, I'm ready to multiply by the 2. 2 times 4, this 4 in the ones, is going to be 8. 2 times 3 is going to be 6. 2 times 4 is going to be 8. And now I have this partial product matching what's in the standard algorithm. So I have 2 part answers that I need to add together to find the exact answer. So 4 plus 0 is 4. 3 plus 8 is 11. So I bring down my 1 and carry my 1. And then I have 6 plus 4 is 10, plus 1 more is 11. So bring down my 1, carry my 1. 1 plus 8 is 9. So 9,114. So let's practice by just solving using standard algorithm. So practicing without doing the area model, but try to remember the steps, because every time we do the multiplication, we're following patterns and steps. So first thing I'm going to do is I'm going to multiply by the ones in 23. And I'm going to go 3 times 3, 3 times 2, 3 times 1 for the first partial product. So 3 times 3 is 9. 3 times 2 is 6. 3 times 1 is 3. So there's my first partial product, 369. I'm going to cross off my ones, the 3 ones, and I'm going over to the 2 tens. That means my answer needs to be starting in the tens column. I need a 0 in the ones column. So 2 times 3, that's 6. 2 times 2, that's 4. 2 times 1, that is 2. There's my 2 partial products. Let's add them together. So now I have 9 plus 0 is 9. 6 plus 6 is 12. Carry the 1. Bring down the 2. 3 plus 4 is 7. Plus 1 more is 8. And then 2 plus nothing is 2. So 2,829. Let's go ahead and do C. 312. Multiply it by 32. So once again, I'm starting in the ones column in 32 and doing 2 times 2, 2 times 1, 2 times 3. So that's 2 times 2 is 4. 2 times 1 is 2. and 2 times 3 is 6. I'm done with the ones in 32, and I'm going to go over to the tens in 30. So that means my answer starts in the tens column, 0 placeholder. So 3 times 2, this 2 up here in 312, that's going to be 6. 3 times 1 is 3, and 3 times 3 is 9. There are my two partial products that I have to add together right here. 4 plus 0 is 4. 2 plus 6 is 8. 6 plus 3 is 9. And 9 plus nothing is 9. So we get 9,984. So let's do some word problems. Here we go. So number 3, we have Betty saves $161 a month. So she saves $141 less each month than Jack. So that tells you that Jack saves more. The question says, how much will Jack save in 2 years? So we're only looking at Jack. We're not worrying about Betty. And we're figuring out how much they save in 2 years. Jack saves in 2 years. Okay, so let's think about this. So let's kind of draw a tape diagram. This is Betty, and we know Betty actually saves $161. So that tells you in the word problem she saves $161 per month. Well, Jack, it says that Betty saves less than Jack. So that means Jack saves more. So we know Jack saves the same amount as Betty, so 161. And then since he has more money, he actually has $141 more he saves each month. So Betty has less, $141 less than Jack does. They want to know how much money does Jack save in 2 years. So if this is how much he saves in a month, 161 plus 141, we can quickly figure out that Jack will save $302 each month. Okay? Now, they want to know how much he will save in 2 years. Some of us that don't read very carefully or comprehend the question carefully enough might take $300 and multiply it by 2 because they see the 2 here. But guess what? This 302 is for each month. And if we multiply it by 2, we're showing that this is how much money he saves in 2 months. We want to know how many he saves in 2 years. So this is not going to be correct because that will give us for 2 months. So we do know that 1 year has 12 months. So 2 years would be 24 months. So now we're multiplying 302 times 24. So let's go ahead and write 302, 24, and then let's do a standard algorithm since we're pretty good at doing that instead of an area model. We're going to start with the ones. So 4 times 2 is 8. 4 times 0 is 0, and 4 times 3 is 12. So I have 1,208 as my first partial product. I'm done with the ones in 24, and now I'm going to be doing the tens, the 2 tens, and so that means my answer starts right there in the tens column, 0 placeholder. So then 2 times 2 is 4. 2 times 0 is 0, and 2 times 3 is 6. Give you the answer right there. There's my 2 partial products. Quickly add them together so that you have 7,248 as your number. And this actually means money. So now we can answer the question as a sentence. How much will Jack save in 2 years? So a simple sentence would be Jack will save ... $7,248 in 2 years. Or if you don't want a dollar sign, you need to make sure the word dollars is written after the number. And you need to also state that it's in 2 years. Or you can put 24 months if you would like. But this is your actual answer. Even though this is what we solved, your answer needs to be in sentence form whenever we do a word problem. Because whenever they ask you a question, you're not going to just say 7,248. You need to say it into a sentence, a complete sentence, so that you're answering the question completely. All right, and let's jump down to the last word problem. All right, here we go. Number 4, Farmer Brown feeds 12 and 1 kilograms of alfalfa. So let's circle 12.1, 12 and 1 kilograms of alfalfa each to his 2 horses daily. So 2 horses eat 12 and 1/10 kilograms each, not all together. How many kilograms of alfalfa will all his horses have eaten after 21 days? Draw an area model to show our thinking. All right, so let's kind of just draw this out a little bit, or kind of just put it our thinking down using kind of pictures or just tape diagrams. Here's horse number 1. Horse number 1 eats 12 and 1/10 kilograms. Horse number 2 does the same thing each day. So we need to figure out how much alfalfa all his horse eats in 21 days. So it looks like we need to possibly add these together first. That's 12 and 1/10 plus 12 and 1/10, and that's going to give you 24 and 2/10, and that's kilograms. So both horses all together each day will eat 24 and 2/10 kilograms. So we want to figure out after 21 days. So we're doing 24 and 2/10, and we're multiplying that by 21. Now I'm going to kind of darken that decimal because we really haven't introduced decimal multiplication yet. But I want to go ahead and just kind of intro it today so that when we get to those later on lessons with decimal multiplication, you'll have a good foundation to solve. So I'm going to rewrite 24 and 2/10, and I'm going to take that decimal away, and I'm going to say that it's 242/10. So please write this down and follow what I'm doing. The reason why I'm putting this word tenths behind it for unit form, that tells me that 242/10 is the same thing as 24.2. So this does have a decimal in it, but I took it away and gave it a unit name at the end. And then I'm going to multiply it by 21. So let's do our area model really quick. So let's do an area model down below. Try to do it as nice and neat so it keeps everything organized. And we're going to take 242 and we're going to break it up. So we have 200 and we have 40 and we have 2. But we are going to keep remembering that this is still a decimal, and so I need to put that word tenths next to it. So 242/10. So let's draw our lines. And then let's go ahead and multiply it by 21. Remember, the 1 needs to go first, the 20 goes second, because that's how we do it in standard algorithm. So 1 times 200 is 200. 1 times 40 is 40. 1 times 2 is 2. So we get 242 tenths. Write that down. Now, for 20 times 200, well, 2 times 2 is 4, and then there's 3 zeros that we need to add, so it's going to be 4,000. Then 20 times 40, so 2 times 4 is 80, and then multiply or add those 2 zeros for 800. And then 20 times 2 would give you 40. So now you have 4,000 840, and we're going to write the word tenths next to it as well. Because technically what we're doing here is we're multiplying the 20 and the 1 with this number up on top. And it's going to be a decimal, and it's going to be tenths. So that means these partial products are going to need to be tenths as well. And so what I want to do here is I'm going to change 242 tenths to be a decimal. So that's going to be 24 and 2 tenths. How I knew that is because if this is tenths, this 2 needs to be in the tenths column. And then the tenths is right after the decimal, so I put my decimal in between the 4 and the 2. So down below, 4,840 tenths, well, since this is going to be a decimal, that 0 needs to be in the tenths column. That means my decimal point needs to go in between the 4 and the 0. So if I do 0 and line everything up, decimal point is lined up with the decimal point up on top. 4, 8, 4. Now I can add these together. 2 tenths plus 0 tenths is 2. Put your decimal point. 4 ones plus 4 ones is 8. 2 tens plus 8 tens, that's 10 tens, which you need to carry the 1 over to the hundreds and bring down the 0. And then 100 plus 400 is 500. So we have 2 kilograms, since we're talking about weight of alfalfa. So let's go ahead and answer the question. How many kilograms of alfalfa will all his horses have eaten after 21 days? So our sentence would be using the question back into our answer sentence. All of his horses will have eaten 508 and 2 kilograms of alfalfa after 21 days. Kilograms is required in your sentence. The word alfalfa describes what the kilograms actually mean. And having it said after 21 days means that you actually multiplied the original numbers by 21 to get the total number of kilograms. So once again, having a final answer as a number is one part. The next part to actually submit your answer on any word problem is to write it out as a sentence, because they're asking you a question. So you always want to restate your question back as a statement or an answer. And that will end our lesson 5 for module 2, intro to actually multiplying our big numbers. And we're going to go ahead and get more complex in the future lessons. So I'll see you on the next one.